Hi friends, in this video we will try to understand when you connect a ammeter in parallel instead of connecting it in series, what happens, and also instead of connecting the voltmeter in parallel, if you connect the voltmeter in series, what will happen. So just we will see, for example, this is the element. So this is a electrical appliance. I want to measure the current flowing through this electrical appliance. So the resistance of this electrical appliance is, let us say, R. Now if I need to connect an ammeter. So this is an ammeter. I need to connect the ammeter in series in order to measure the current flowing through this particular element. I need to connect the ammeter in series. But instead of connecting it in series, if I connect the ammeter in parallel, let us say this is the appliance whose resistance is R. Instead of connecting an ammeter in series, if we connect an ammeter in parallel, so this is the ammeter, so I have connected this in parallel. What happens if I connect the ammeter in parallel? Ammeter generally has very low resistance. Ammeter generally has very low resistance. Now, when we connect the ammeter in series, the current always chooses low resistance path. Out of this resistance and the resistance of this ammeter, the ammeter resistance is very small compared to resistance of the appliance. Therefore, the current flowing through the ammeter is very large compared to current flowing through the appliance. Hence, the ammeter will be damaged. So, when you connect an ammeter in parallel instead of connecting it in series, the ammeter will draw heavy current so that it will be damaged. We have one more question related to the same concept. So, this is the appliance whose resistance is R. In general, to measure the voltage or potential difference across this appliance, we connect a voltmeter in parallel. So it is the actual connection. But instead of connecting the voltmeter in parallel, if we connect the voltmeter in series, let us suppose this is the appliance whose resistance is R. Instead of connecting the voltmeter in parallel, if we connect the voltmeter in series, what happens? So actually voltmeter is a high resistance instrument, means it has very high resistance. Now when we connect this voltmeter in series to the appliance, the entire resistance of this path increases, because we know that in series the equivalent resistance is larger than the largest. Therefore, when you connect a voltmeter in series to the appliance, the resistance of this path will be increased a lot. Therefore, when the resistance increases, we know that the current flowing through a particular path depends upon the resistance of that path. If the resistance is very high, the current flowing through this path is very small, so that the voltmeter will not show proper reading. Why? Because the current flowing through the voltmeter is very small. Whether it is a voltmeter or ammeter, the deciding factor is the current flowing through that meter. If the current flowing through the meter is very small, we cannot see the reading of the voltmeter properly. That's why we generally avoid connecting the voltmeter in series to the appliance to measure the potential difference. So the takeaways from this video is, first takeaway is, we should not connect an ammeter in parallel. So ammeter should not be connected in parallel. When you connect the ammeter in parallel to the appliance, a large amount of current will flow through the ammeter, so that the ammeter will be damaged. So it should not be done. Second takeaway is, voltmeter should not be connected in series. When we connect the voltmeter in series, the entire resistance of the path increases, which reduces the current drastically. So we cannot get a proper reading from the voltmeter. So we should not connect voltmeter in series. So these are the two takeaways from this video. If you like this video, please share and subscribe to my channel. If you have any doubts related to this video, please post them in the comment section so that in my free time I will try to answer these questions. Thank you very much.